information. So it's a work we have done with a lot of core audit over the last years. It has been published earlier this year in Nature Climate Change, and I will go over it as a kind of an introduction to the session of what has been happening in previous IPCC scenario ensembles. So we have now like a decade of large-scale IPCC ensembles, scenario ensembles. So looking into mitigation scenarios, specifically from AR5, which was published in 2014, and covering scenarios up to 2014, basically, up to AR6, which was like published in 2022, actually scenario based and cover scenarios until then. And we also have some in between ensembles. Well, we have the special report of 1.5, covering scenarios basically from 2015 to 2018, and also have all the database of the special report on emission scenarios, which were mostly baseline scenarios published around 2000. So these four ensembles will be covered in this analysis, mostly the latter three. And we look at how they have been evolving over time, and what is behind that, and what does that say basically. So we overseen by, if we compare like baseline scenario, which is where we also can compare it with the special report of emission scenarios from around 2000. Where we can see of our no policy based scenarios are getting less pessimistic basically over time. So here we see the emissions medians and the quartile ranges for the different reports, going from the oldest on the top, the yellow, to the latest, the AR6 in green. And we see that certainly for 2050 we see like nearly 10 gigaton decrease, only due to basically lower without any policy. So only due to more optimistic projections on, for example, GDP, the population, technology, the more favorable, at least for climate. And also importantly, we see how it compares to projected to real world estimates of emissions. So in 2010 and 2020, where 2020 is like we take the average of 2019 and 2021 to avoid the COVID effect, where we see that in 2010 most scenarios in all packages actually underestimated emission growth until 2010. So it was probably because of the high growth of emissions more than expected in China that most of these scenarios underestimated this. But in 2020, most ensembles actually overestimated, except for kind of the AR6, because it was kind of already nearly observing the emissions until 2020. But the earlier ensembles kind of overestimated emissions in 2020. And we see that overall, then afterwards, it was 2050, that in general, this trend of overestimation, or maybe not overestimation because we don't know yet, of course, but there's a trend of towards estimating lower emissions into the future in the absence of policy. Then we also see that mitigation requirements are getting increasingly steep, because although baseline scenarios maybe have been like overestimating emissions, like also we have mitigation hasn't been strong enough to be on the path of what, in, for example, in the AR5 scenarios in 2014 was necessary to achieve climate targets. So when we compare the 2020 values or emission values in 2 degree compatible and 1.5 degree compatible between the AR5 ensemble in published in 2014 and the AR6 ensemble published in 2021, we see that there's like since AR6 had to account for this higher increase in up to 2020, basically, it also had to reduce more steep, and which means that emissions at 2050 relative to 2020 in AR5 only had to reduce like 53% and AR6 by 80%, which is of course a very different story in terms of how mitigation can be done. When we look at the different factors of contributing to that reduction, to that required reduction in 2050, according to our mitigation scenarios. So we look at 1.5 compatible scenarios, and we do a decomposition, which means that we separate the effect of the average scenario into different factors. And we see that an important reduction, which the second factor, GDP per capita, is this reduced by about 20%. So 20 of the total impact of emissions, which is like as you see, actually, I don't have a pointer here. Or do I? Yes, I do actually. So as we see here, that these are aligned with a more steep decarbonization pathway as we need in 2050. A big contribution to that is this reduction in GDP per capita. So this is kind of the less the economic projections, GDP projection, growth projections are less optimistic, better for the climate, but less optimistic for our economy in AR6 compared to other packages. And also from SR 1.5, we also saw a higher decline in CO2 intensity of energy, which made a lot of impact. So it's basically the impact of renewable energy that contributed to this decline. While on the other hand, CO2 capture CCS actually decreased the role, and also the role of energy efficiency kind of decreased towards AR6. If we look at emissions by sector, we see actually the same figure as we saw here, but separately for every sector. So we see that indeed, so emissions in 2020 are increasing in every sector actually globally, and except for AFOLU. And that made that the 1.5 emission pathways, which are the dotted ones here, had to be more increasing up to 2020, and then a higher decline. We see that it's the same for every sector, for energy supply, for industry, for buildings, slightly for transport, and also for AFOLU. So AFOLU also had, like, in the latest projections, have very negative projections, very negative emission projections for 2050, while this was less the case in AR5. When we look at how the transformation has occurred in these scenarios, we are doing this by these kind of figures, where we show to equal cumulative emissions. So on the x-axis, you see cumulative emissions from 2010 to 2050, which are for which we compare the different scenario ensembles. So we see in the red, not included here as legend, in the red we have AR5 scenarios, the interquartile ranges of AR5 scenarios, and in the green the interquartile ranges of AR6 scenarios, and in gray the one of the special report of 1.5. So we see that the coal share has significantly declined, also for more moderate mitigation pathways, has declined from like 15 to between 5 and 10% in many scenarios. The gas share kind of was similar for 2 degree compatible scenarios, but then reduces for 1.5 scenarios due to more stringent, I guess, more stringent overall mitigation requirements in AR6 compared to AR5. Bioenergy actually is overall slightly lower, but similar when we go to more stringent mitigation pathways, and most clearly, the share of wind and solar in primary energy has increased a lot from AR5 to AR6. In AR5 it was on 10%, and then AR6 it goes up to like 35%. When we look at some other indicators like the electrification of final energy use, we see the same trend of AR5 scenarios being consistently lower, even with the same mitigation cumulative emissions compared to AR6 emissions, and also renewables and electricity. So we see a very clear tendency towards electrification in scenarios and towards more renewables in electricity. And despite the higher electrification, we see actually a lower share of nuclear electricity and also a lower share of carbon capture and storage in AR6 scenarios compared to AR5 scenarios. So overall, they represent really a higher reliance on solar and wind and lower on nuclear and CCS. Then also the cost of the transition, which is a very important variable in IPCC reports, was lower overall. So it was actually for 2 degree compatible scenarios, it's significantly lower. It's like about half compared to AR5 scenarios. For 1.5 compatible scenarios, it gets in the same magnitude, but important to understand here that the mitigation target is much more stringent in AR6 scenarios. So even with a more stringent mitigation scenario, the cost of the macroeconomic cost of achieving the target is similar, and it's not taking into account climate feedback. So just the cost of mitigation itself. And when we look at the reasons behind this, an important one might be actually the strongly declining cost of renewables. So certainly of solar PV, we see actually the cost at AR6, the projections in 2050 being significantly lower than AR5, and actually still above what is actually observed according to ARENA in the last years, and the similar figure in less magnitude we see for onshore wind. So overall takeaways for discussion from this analysis is that the decarbonization, we can see it as a moving target. So the pathways are highly influenced by socioeconomic and technological projections, and also the state of the models are very important. So lagging behind reality in a model provides like a skewed view of what the optimal mitigation pathways really is. It might, by not representing some dynamics, you may over rely on bioenergy or on CCS or nuclear if that is seen as a backup option. And also that geographical and political influence on decarbonization pathways, which I haven't commented, but it's part of the paper, may also be important, as a high relative share of EU-produced scenarios are EU-produced scenarios, and the EU has seen a sort of strong shift in focus towards renewable electrification towards AR6. So this has probably been driving the difference that we have seen in the figures. And also socioeconomic projections towards the future may be affected by political expectations and are traditionally overestimated. So we saw like overestimation of GDP projections in future, which may be also driven by political objectives. So these are the takeaways from my part. I guess now we switch to Glen.
Perfect. Thank you, Dirk. And thanks for this great presentation. And then, yeah, Glen, the floor is yours. So to give us the other side of this analysis.
Okay, thank you. So I'm going to talk about the next generation of scenarios, but to do that, I'm going to touch a little bit in the past, go over the same time period that Dirk talked about, and then and conclude with thoughts on the next generation of scenarios. And I'm going to talk about 4 phases of scenarios through this time period, if you like. So the first phase of scenarios used in the IPCC, sort of more or less from 1990 up to around about 2005, 2007, is a phase that was driven by the IPCC process. So the IPCC initiated and was heavily involved in the scenario process. They were baseline scenarios without climate policy and considered the full range of the literature. And this just gives you a snapshot of those scenarios. I'm not going to go into too much detail in Dirk's presentation. You saw the SRES in here. Main point here is to point out that in this IPCC process, there was a focus on baselines, so no climate policy included, focus on the full range of scenarios in these baseline scenarios, so to span the literature. Another point worth noting is these scenarios have been used differently in the reports, different IPCC reports over the years. So the SRES scenarios, for example, generated around about 2000, but they still had their fingerprint in, for example, the fifth assessment report in 2014, particularly in the climate impact. So this scenario generation process and the use of some of these scenarios can be quite long in the literature. So that's the phase, what I called phase one. I didn't want to focus too much on those older scenarios, but moving to what I've called phase two here, which is more community driven. So the IPCC outsourced the generation of scenarios to the community, the research community. I put in brackets here IPCC because this didn't happen in complete isolation of the IPCC. They help initiated processes and so on. These are, I've called them marker scenarios. Some of you may have heard of or know of scenario MIP, and again, it considered the full range of scenarios. So this process of scenarios in this phase two has been quite influential, and I'll sort of come back to why. So one of the IPCC convened an expert meeting in 2007, and one of the issues that came up there is that the linear process to generate scenarios is very slow. To go from the socioeconomics through integrated assessment models to climate models to impact models could take 10 or 15 years. And as I mentioned, these SRES scenarios were used for about 15-year time period because of this slow nature. So at this meeting in 2007, they decided on this, what's become known as the parallel process. So they started in the middle and worked in parallel. So this is a complex looking figure with a lot of text on it, but a few familiar components when I put in these next steps. The scenario process started at concentrations, RCPs, representative concentration pathways, that I'm sure many of you have heard. And then after that, it went into a parallel process. The big climate models started to run their scenarios, these RCPs, and this became a very big component of the fifth assessment report, working group 1. In parallel to that, the integrated assessment modelers started to generate the socioeconomics that would sit behind these RCPs. This led to the shared socioeconomic pathways, the SSPs, which were an important component in SR15, the special report on 1.5 degrees, but were relatively small components in, for example, AR6. Then there was meant to be this phase of these scenarios converging together. I would argue that this didn't really happen, and the impacts or the use in impacts research has also been a little bit subdued. You know, you could have arguments different ways. Maybe some people would disagree with this, but in my view, at least, this merging of these scenarios did not really happen as was originally envisaged. And just pointing out that this was meant to wrap up in 2013 to feed into the IPCC fifth assessment report. But, you know, maybe in best case scenario, you could say some of this overlapped into the sixth assessment report. So it took some time. This is highlighting the slow nature of this scenario process. Something that's happened in the recent years, you know, there's been a lot of this focus around concentration pathways, RCPs, but the research community is starting to recognize this is maybe not the best way to incorporate the full uncertainties in the system. So now there's a push for more emission-driven scenarios, and this is because carbon cycle feedbacks are very important in the climate system. That's just a little side point which is very relevant moving forward. Just a quick few figures. These are the representative concentration pathways. They were, you know, sort of, the process started around about 2007. you still do see elements of these in Working Group 1 and Working Group 2. Working Group 1 in the 5th assessment report, definitely. Another point worth mentioning is that these scenarios often have very similar fingerprints to earlier generations of scenarios. So if you look into the details, you'll see SRES elements in here and so on. The shared socioeconomic pathways, the SSPs, were also quantified and marker scenarios selected, which is the ones in bold here. These went into the big climate models that were used in Working Group 1 and Working Group 2 in the 6th assessment report, but they had a pretty weak footprint in Working Group 3. I'll come back to that in a minute. And at the moment, there's a process to generate the next set of marker scenarios for the next assessment report, AR7. You know, there's a paper in review here, but I think you'll see some similar fingerprints to the earlier generations of scenarios. I won't go into too much detail there. So phase 3 of the scenario process, I've called the Wild West, and you'll see why in a minute. This is again community driven, although not naive to the IPCC. And the Wild West has come from the use of voluntary submissions. So here is a snapshot of the scenarios in the 6th assessment report. You can have a similar figure for the 5th assessment report. There's a lot of scenarios there. There's about 1,200 scenarios in this figure. And one thing that you'll notice is there's a big dominance on mitigation scenarios around this 1.52 degree space, not so much in terms of baseline scenarios, and this sort of represents this shift to the community as opposed to the IPCC driving the process. One thing with the voluntary submission process is you don't have to submit to the process, or you can submit a lot of scenarios. There were no, outside of quality control and various things like that, there was no limits on who could submit scenarios as long as you had a certain type of model and so on. And so you see across all the scenarios submitted to the database, the green ones in this figure are used in the assessment in terms of climate assessment. And you'll see there's a couple of models there which really dominated the submissions. And that means when you look at results in the IPCC, you will see the fingerprint of those different models. That doesn't mean the models are good or bad. It's just a consequence of having a voluntary process to submit scenarios. In terms of projects involved, this dominance of certain projects is more evident. Here's one project, Engage, with about half the assessed scenarios. Another big project with a lot of scenarios didn't have their scenarios get a climate assessment, and so they had much less focus in the report. So again, this is sort of why I called it the Wild West, in the context of you have limited control over the scenario submitted to the database. So moving a little bit towards the next generation and a couple of reflections on that. If we did the same again in AR7, what would we expect from this process? This figure here shows the 1.5 degree scenarios in the AR6 database with limited overshoot, and our current emissions in black there. And I sort of asked the question, what new policy relevant information can come out of these global scenarios? And I wrote a commentary a year ago in a new journal called Dialogues on Climate Change. We no longer need scenarios with impossibly steep emission declines to 1.5 degrees, but more nuanced country level scenarios integrating national circumstances and feasible ambitions. And this is sort of coming to the point that we know the big picture, we know what needs to happen. Now the next phase is to start to get to implementation. And this is where I talk about the next generation of scenarios, hopefully much more user driven and hopefully much more granularity at the country level, sector level, and much more nuance. And so to sort of, what does that mean? So we know the climate problem quite well. We've studied it to death from the science perspective. We know what needs to happen globally. It's now about implementation. We know that policy happens at the country level and at the sector level, and national circumstances are very important. They can't be ignored, so things like global carbon prices are not so relevant when you're moving to the national level. So the next generation of scenarios, I would argue, need to be much more focused on research questions, policy-driven research questions, careful identification of the user and the user needs, much more granularity, country, region, sector level, multiple lines of evidence. So we just don't use one model, but maybe multiple models, multiple methods, different types of methods, different types of knowledge in assessing the research question. Much more rich and diverse policy mixes, not focusing on things like carbon prices, as they're not that common in a policy context. Bringing in much more national circumstances, issues of feasibility brought into the question, not a post-analysis, realism and things like that. Most of the scenarios to date, particularly the ambitious ones, are based on backcasting. So you pick the target where you want to get, let's say 1.5 degrees, and figure out how to get there, particularly over a long time frame. This is not really how policy works. It's more of a forecasting problem. Implement your policies and see where we go. When we think about the global optimized backcast scenarios coming from these big global models, they will still have a role, particularly in things like big trade-offs, long-term, short-term action, target setting, and so on. But they will have much less, or they do have much less relevance, I would argue, for the development of national level policy. So the next generation of scenarios will be a rich mosaic of scenarios. There'll be a lot more variation, a lot more difficult to assess, and therefore we would need a much more systematic approach to how we assess scenarios when we go into the next assessment report. And with that, I'll finish up. Thank you.